In this lesson, we're going to talk about how to reflect a point across the x-axis, the y-axis, the origin, the line y equals x, y equals negative x equals k, and y equals k. So let's say we have a point with the ordered pair x comma y, and we want to reflect it across the x-axis. What will be the coordinates of the new point? Whenever you reflect it across the x-axis, the x values will remain the same, but the y values will change. It's going to change from y to negative y. When you reflect a point across the y-axis, the y values will stay the same, but the x values will change. And when you reflect a point across the origin, both x and y will change the sign. And here's a visual picture for that. So let's say we have the point xy here. If we want to reflect it over the x-axis, it's going to move to this point. So let's put some values. Keep in mind, this is the x-axis, this is the y-axis. So let's say this was the point 4, 3. When we reflect it over the x-axis, x is going to remain 4, but y is going to change from positive 3 to negative 3. Now, if we want to reflect that point across the y-axis, it's going to move across the y-axis, and it's going to move here. This time, the x value will change. It's going to change from 4 to negative 4, but the y value will remain the same, positive 3. Now, if we want to reflect it across the origin, here's the origin. It's at the point 0, 0. It's going to go right here. Both x and y will change. So it's going to be negative 4, negative 3. Now, let's say we have the same ordered pair, x comma y, but this time we're going to reflect it across the line y equals x. This will give us the inverse function, and the new coordinates will be y comma x. So what we're doing here is we're switching the x and y values. So let's go over a visual representation of this. This is the line y equals x, or at least a rough sketch of it. And let's say we have the point 2, 5. Let's say that's right here. When we reflect that across this line, it will give us this point, which is 5, 2. So when we switch x and y, we're going to have 2 points that are equidistant from the line y equals x. Here's another way to see this. So this is the graph y equals the square root of x. And this is the graph x equals the square root of y. They intersect at the point 1, 1. But you can see that they reflect across the line y equals x. They're inverses of each other. The blue graph has the point 4, 2. When x is 4, y is 2. And that's going to be somewhere over here. The red graph have the point 2, 4. When y is 4, x is 2. The square root of 4 is 2. And you can see those 2 points, they're equidistant from the line y equals x. So that's what happens when you reflect a point across the line y equals x. To get the new point, all you need to do is switch x and y. Now, what if we want to reflect the point across the line y equals negative x. In this case, you're going to get the negative inverse of the original point. So we're going to switch x and y, but we're going to apply a negative sign to both. So that will give us the new point if we try to reflect it across the line y equals negative x. Now let's draw a visualization of this. So here's the line y equals negative x. It passes through the origin like the other line. The only difference is it has a negative slope. Now let's draw two graphs. So this graph here in blue, that is the graph y is equal to the square root of negative x. This graph here, this one is x is equal to negative square root y. On the blue graph, I'm going to need space, so I'm going to erase this. I'm going to put this here. On the blue graph, we have the point negative 4, 2. If we were to plug in negative 4 into that equation, it will be y is equal to the square root of negative 4. It will give us a positive 2 for a y value. Now, to get the other point, the reflected point, what's going to happen? Well, first, I'm going to put this over here. I'm running out of space. So this is x, this is y. X is going to move over here, but it's going to be negative x. So here was negative 4, now it's going to be positive 4. Y is going to move here, but it's going to be negative y. Y was 2, so negative y would be negative 2. So these are our new x and y values, but getting it from these values, this is how we have to change it. So if we plug this into this equation, we can see that it's going to work. Y is equal to, well, technically, we're plugging into this equation here. X is equal to negative square root y. So y is positive 4. The square root of 4 is 2, and we get negative 2. And we can see that these 2 points, they're equidistant from the line y equals negative x. So to review, anytime you need to reflect a point or an ordered pair across the line y equals negative x, you need to find the negative inverse. So first you find the inverse by switching x and y, and then you negate the values of x and y by changing the signs of x and y. So find the inverse and then change the sign. That's how you can reflect a point across the line y equals negative x. So xy becomes negative y, negative x. Now let's say if we want to reflect a point across the line x equals k. What will be the new point? So let me let you think about that for a moment. Now let's draw a picture. Let's say we have the line x equals 3. We want to reflect a point across that line. And let's say we have the point five, 2, which is here. When we reflect it across that line, what's going to happen? What will be the new point? The new point will be here. it's going to have an x value of 1. So notice that the line that we reflect across, it is the midpoint of the x values. K is the midpoint. So to go from 5 to 3, we traveled k units to the left. To go from 3 to 1, we traveled another k units. So to go from one x value to the other, we got to travel 2k units. It turns out that to get k, this number, from these two, k is the midpoint of 1 and 5. So if we call this x1 and x2, when we take the average of them, it gives us k. If we were to multiply both sides by 2, we would get 2k. So to get the second x point, it's simply 2k minus 1. So if this is our original x value, the new x value will be, this is 2k minus x1. I put 1 here. So the new x value will be 2k minus the original x value, which was here. Now this line, x equals k, it's parallel to the y-axis. So the situation is very similar to reflecting a line across the y-axis. Whenever we reflect a point or a graph across the y-axis, the y values, they stay the same, but the x values change. So both the y-axis and x equals 3, they're vertical lines. In that sense, they're similar. So that's why the y values, they stay the same, because we're reflecting across a vertical line. So let's use this formula for the example that we have. This point here is 5, 2. Let's get the new point using this. So 2k minus x, k is 3, so it's going to be 2 times 3 minus our x value, which is 5. 2 times 3 is 6, minus 5 gives us 1. So we get the point 1, 2, which is exactly what that point is. So that's how you can find the new point using that formula. Let's try some more examples with that. So let's say we want to reflect it across the line x equals -2. Go ahead and find the new values, or the reflected values, for this point here, which is -5, -3, and also let's say this point here, 1, 2. So let's start with the point 1, 2. We want to reflect it over the line x equals -2. So k is -2. So it's going to be 2 times -2. Let's use brackets. And then minus x. X is 1, 2. 2 times -2 is -4, minus 1, that's going to be -5. So the new point is -5, 2. And if you think about it, to go from this point to the line, we need to travel 3 units to the left. So to get the reflected point, we need to travel another 3 units to the left, and it's going to take us here, which is at -5, 2. Now let's do the same for the other point, -5, -3. Let's reflect it about the line x equals -2. So it's going to be 2 times k, k is -2 in this example, minus our original x value, so that's -5, 2. So 2 times -2 is -4, and then minus -5, that's +5. -4 plus 5 is 1, so we get the point 1, 2. Actually, I changed the y values, so the y value should remain -3. I don't know why I did that, but let's correct it. So the y value shouldn't change, only the x value. So the point 1, -3 is right here. And we can see we're 3 units away from the line x equals k, and as we travel another 3 units to the right, it'll give us this point, 1, -3. So that's the reflected point across the line x equals -2. So that's how you could use this expression to find a reflected point about the line x equals k. Now I want to show you something. If you recall, when we reflect the ordered pair xy about the y-axis, the y values remain the same, the x values change. So we got -x comma y. But remember, the y-axis is basically the equation x is equal to 0. So when reflecting about the line, about the y-axis, we're also reflecting about x equals 0. So in this case, k is 0. Let's apply that k value to this formula. If k is 0, this becomes 2 times 0 minus x. 2 times 0 is 0. 0 minus x is -x. And we get this expression. So this expression can come from this equation. You just have to realize that when you're reflecting about the y-axis, you're reflecting about the line x equals 0, where k is 0. So if you know this equation, you can definitely get this answer as well. Now let's go back to our original ordered pair. This time, we're going to reflect it about the line y equals k. Now the line y equals k, that line is a horizontal line that is parallel to the x-axis. So it's similar to reflecting about the x-axis. When you reflect about the x-axis, the x values stay the same, but the y values will change. So for the other one, it was 2k minus x comma y. For this one, it's going to be x comma 2k minus y, where y is the original value that we had here. So let's work on an example. So let's say we have, the line y equals 3. So we're going to reflect it about that line. And let's say we have the point 3, 7. What is the new point using this expression if we reflect it about the line y equals 3? So 3 comma 7 will become, x will remain 3, but y is going to change. There's too many 3's here. I have 3's everywhere, so that could be confusing. Let's adjust this a bit. Let's make this 5, 7, so we don't get confused by the many 3's that we would have had. So this is the point 5, 7. Go ahead and reflect it about the line y equals 3. So the x value will stay the same. The y value will change. K is 3. So this is going to be 2 times k, or 2 times 3, minus our original y value, which is 7. 2 times 3 is 6. 6 minus 7 is -1. So the new point is going to be 5, comma, -1. 5, -1 is right here. And we can see they're equidistant from the line y equals 3. If we travel 4 units from 5, 7, it'll take us to the line y equals 3. And then if we travel down another 4 units, we're going to go from 3 to -1. So that will give us the point 5, -1. So this is the expression that we need to use if we want to find the new point after reflecting a point across the line y equals k. Now let's say if we want to reflect something across the x-axis. If we want to reflect something across the x-axis, we're reflecting it across the line y equals 0. So k is 0. We get 2 times 0 minus y. This becomes x comma -y. Now let's put everything together. So starting with our original point, x comma y, for the sake of review, if we reflect it across the x-axis, we're going to get the point x -y. If we reflect it across the y-axis, we're going to get the point -x comma y. And then if we reflect it about the origin, we get -x -y. And then if we reflect it about the line y equals x, this gives us the inverse, y comma x. If we reflect it about the line y equals -x, we get the negative inverse, -y -x. And then if we reflect it across the line x equals k, we get 2k minus x comma y. So the y values stay the same. And then finally, if we reflect it about the line y equals k, which is parallel to the x-axis, the x values stay the same, but we get a different y value, which is 2k minus y. So that's a summary of all the things that we've considered today. So now you know how to get the new ordered pair if you need to reflect it over the x-axis, the y-axis, the origin, the line y equals x, y equals -x, x equals k, and y equals k. Thanks for watching.